Okay, today we're going to start a new chapter. We're going to start chapter 3. And throughout this, I might have to review. We're not covering chapter 2, but there's some concepts in chapter 2 I might have to stop and review a little bit before we move forward. Give me just 1 second so I can put this in the right folder. So chapter 3 or 3A is going to be about percentages. So we're going to talk really about the uses and abuses of percentages is what your book goes over. So I'm going to go to the desktop camera a few times just back and forth, but overall, we're just going to talk a little bit about this. The math side will happen, but we see a lot of this in the real world, a lot actually. The use of percentages. Your book goes over 3 ways that that we see percentages used in the real world. The first one is just using them as fractions. So I'm gonna click over to the desktop camera real fast and give some examples of this and where it comes from. So yeah, section 3A. Okay, let's consume it. So a brief review of fractions. If you know, your book does a good job actually at the very bottom right on page 121 to review these. But remember, the word percent really means per 100. Cent means the 100th. So percent means out of 100. So if of course if we had something like I made a 73% on a test, and now if there were exactly 100 questions, then that would mean you would get 73 out of 100 correct, right? 73 out of 100. But it's just another way to write it. So why is it focusing so bad? Come on. Oh, you can't see anything? Hold on. Is that better? When you say you can't see anything, Weston, what do you mean by that? Like it's blurry or it's all black? All black, but I can see names. Okay. That's weird. Are you guys having the same problem? Ava, Michaela, Emily? Yeah, it's extremely blurry. That's why I'm having a blurry issue. I can see, but blurry. Okay. Listen, I'm not sure why you can't see. See, it's trying to bring it into focus. That's weird. That's a little better focus. Yeah. Leave and come back and see if that helps. I'm gonna keep rocking and rolling. Okay. So yeah, that's definitely blurry. Better on the blurry issue going on. So yeah, anyway, so percent really comes from, if you see a percentage, it just means out of 100. Now, there might not have been 100 questions. It's just the percentage that the person got right? So if we look at something basic like, let's say, Shaq's free throw percentage throughout his entire career. So 52.7% is Shaq's free throw percentage throughout his career. Now, if we wanted to write that as a fraction, of course, it's 52.7 out of 100. So what we should expect is if he makes 100 or takes 100 free throws, he should get 52.7, or he should make 52.7. Now we know, of course, he can't make a seventh of a free throw, but because this is averaged out over his entire career. But it tells us the likelihood of him making a free throw, which is kind of neat. Okay, for this example, that's what that means. Now, also, you can convert this to a decimal. So let's go back to the 73%. It's 73 over 100, which is actually just 0.73. Okay, and then 0.73. So the same with 52.7. This is going to be 0.527. Okay, all 3 of these are the same exact number, just written 3 different ways. You've got the percentage kind of notation, you've got the fractional notation, which there has to be 100 on bottom, and then you have the decimal notation, which our decimal notation is base 100. That's why, or base 10 actually. but that's why it converts evenly to these last two. If you're dividing by 100 or 10 or 1,000, it'll convert easily into a decimal because we have a base 10 numbering system. Okay, so let's now get back to kind of the usages of these percentages. The first one your book goes over is using the percentage as fractions. And it says, percentage is just a fancy way of saying divided by 100, right? Okay, I think I just went over that one. Yeah, so they give an example where an opinion poll finds that 64% of 1,069 people surveyed said that the president is doing a good job. Well, how many said the president is doing a good job? Well, yeah, that's a good. So let's say we've got this survey that said 64% of 169 people say the president is doing a good job. This is the example on 122. Okay. Well, how many does that mean? Let me just say, how many are saying that he's doing a good job? Well, what's nice is it's really easy to convert percentage and numbers together. So you just take the 1,069 people and you just have to multiply it. Now you can either multiply it by the decimal or by the fraction, whichever one's easier for you. I'm going to do the fraction. 64% is just 0.6, not 0.46, but 0.64. And I just pop the calculator open and I just multiply those two numbers together. 1,069 times 0.64. And you wind up with 684. Now they round. You wind up with actually 684.16. Okay, 684.16. But I'll tell you, you can never have a fractional amount of person. Okay, so for this example, you would always round down, even if it was like 68.49. You can't have a ninth of a person. So technically, you should always round down for this example. Now, if it was just a number that you needed to round, that's different. But for a person, you can't have a ninth of a person or a 16th of a person, right? Or 16% of a person. Okay, so 684. That's a lot of rambling for something basic. So that's the first way. So let's think let's do something real world here. Okay, let's do percent of I'm going to stick with sports. I'm in the sports mood today. Let's say percent of NFL players who end up with a 5-year career. I wonder if we can find that one. Okay. Hold on. I should have done this beforehand, but it was an inspiration. Okay, hold on. Okay, well, I didn't find 4 years. That's it. Now the average length. So this says 50% of players are out of the NFL by their 4th year. Okay, 50% of players are out of the NFL by their 4th year. So I want to know, well, how many players is that? How many players are expected to be retired? But okay, let's use this year's class, so 2020 class. How many players are expected to be retired from that's a from. Good God, that's hard to read. From the 2020 class. So the everyone that starts in the 2020 class, how many players are expected to be retired from the 2020 class by 2024? So I need to find the number of new NFL players a year. So number of new NFL players each year. I'm going to Google that. So there's about 300 openings each year. roughly. Now, guys, these are estimates, right? 300 new positions each year. So what we're saying is we do 300 times 0.50, so 150. So whenever we have a group of like first year players start, so in the year 2020, there's going to be about 300 new players. Okay, there'll be about 300 new players that start in the NFL in the year 2020. By the fourth year, so by 2024, we can expect 150 of those 300 to already be retired, right? Which is crazy. Now, of course, they make a lot of money. So, I mean, the ones that are retired within 4 years don't make as much as the ones that are there, really more than that, because you're getting off your rookie contract and making more money. So I know you might want to say, well, they're making more in 4 years than all of them make. Well, if you really do the numbers on some of this, not really. Okay, actually, yeah, I mean, hold on. Let's see here. Hold on. That's something for another day. I might have you guys look that up. Like how much NFL players actually take home from their salary on a rookie contract, right? After they sign a big contract, that's different. But a rookie contract, how much they're actually taking home after they pay taxes and they pay an agent fee and things, and even like, I mean, the trainers, things of that nature, how much do they actually take home is pretty interesting and kind of eye-opening sometimes. Okay, so anyway, though, let's get back to actually the lecture before I go off on tangents with sports. So the next one, the next way of using percentages, the first is just, is fractions, what we talked about. The next is to describe change, which is often used, right? And your book says percentages are often used to describe how a quantity changes with time. As an example, suppose the population of a town was 10,000 in 1980 and then 15,000 in the 2010 census. We can express the change in population in two basic ways. Because the population rose by 5,000 people from 10,000 to 15,000, we say that the absolute change in the population was 5,000 people. Because the increase of 5,000 people was 50% of the starting population of 10,000, we say the relative change in the population was 50% or 0.5. We'll do some math here in a second on this, but let's define these two as absolute and relative change, okay? Absolute change, your book defines as the actual increase or decrease, okay? Actual increase or decrease. And you just do, new value minus old value. The relative, though, is the size of the absolute change in comparison to the reference value, okay? So relative change is the size of the absolute. Absolute change in comparison to the relative change, right? The reference value. Let's do just a basic example. Let's say on test 1, you make a 75, okay? And then test 2, you make an 84, right? And you want to know, okay, let's find the absolute and relative change for test 1 and test 5. So the absolute change would just be, 84 minus 75. So that's going to be 11 points. So the not 11, 9. Okay, the absolute change is 9 points, right? 84 minus 75 is just 9. But then the relative change, though, if you want to know, well, relatively, what percent have I increased my score? And I'm going to do this. They give you the formula on page 122. I'm just going to pop it in the formula. So first, we take the new value, so 84, minus the reference value. So the value we started with, 75. So that numerator is always going to be your absolute change, right? It's positive 9. And then we're going to divide it by our reference value, so 75. Now you're going to multiply this by 100 to make it a percentage, okay? You're going to multiply it by 100 to make a percentage. So I'm not going to do that first. I'm going to break this down. I'm going to find this fraction first. So if I do the fraction first, so 84 minus 75 is 9. So 9 divided by 75. So 0.2, or 0.12, I'm sorry. 0.12 and then times 100. So you wind up with 12%. Okay, so this is 0.12, and then you multiply it by 100 and you get the percent change. So if you made a 75 on the first test and an 84 on the second test, you've actually increased your test score by 12%. Okay, you've increased your test score by 12%. Okay, let's look at a current kind of topic sweeping social media, and it has to do with this GameStop stock, right? Hold on a second. And we're going to do the same thing and just show how crazy this the stock has changed over. Let's use the last month, okay? Let's do the last month. Okay. So GameStop. Now this is for 1 month. So GameStop. Stock. Okay. Trying to look this up as best I can. So it looks like the furthest back I can go is January 4th. I guess they weren't trading before that because it was New Year's. So on January 4th, get this. January 4th, the stock was trading at $17.54. Okay. So the stock was trading at $17.54. And right now, I'm just going to go off right now. It'll change throughout the day. February 1st, the stock is currently trading at $227.95. Okay. So it's ballooned up from $17.54 to $227.95. Well, let's look at the absolute change first. So the absolute change, right over here. Like if you bought it at $17.54, how much have you made, right? It cost you $17.54 if you bought it on January 4th. How much have you made during that time? Well, you're going to take the new value, 227.95, and you're just going to subtract what you bought it for, $17.54, right? And this winds up being, let's take the old calculator out, 227.95 minus 17.54, $210.41. You would have made $210.41 if you would have bought that stock on January 4th and sold it right now, okay, at $227.95, okay? So now it'll be interesting if I use this video in the future, what this stock's going to be valued. So if you're watching this, next semester or in a year or two from now, look up the price of this and see how it's changed. Okay, so let's find the relative change. The relative change says, okay, we're going to start with the new value, 227.95. We subtract off what we paid for it, the old value, the reference value, divide it by the reference value. Okay, that's the first part. And then you multiply it by 100% to get it into percentage form. Okay, so I'm gonna do this fraction first just to see what we're looking at. So 227.95 minus 17.54, which we know is 210.41. Divide that by 17.54. And we wind up with 11.9. Let's just round it to the thousands place there. 11.996. Now we've got to multiply that by 100% though. So times 100, and we just move the decimal to 1199.6%. Holy cow. So the GameStop price has increased by 1,199.6% from January 4th to February 1st. That is crazy. Something on the lens. Hold on, guys. It's just really blurry today. Okay. That's crazy. Okay. So if you would have your absolute increase is really, if you think of this regular example, your absolute increase would be the dollar amount you made, right? And the relative increase though would be your percentage increase. Let's do one that goes negative. I mean, why not? So think of a stock that's gone down over time. Just to stick with stocks. Sure, lately they're all going up. Hold on. Yeah. Okay, I just chose a random stock that's gone down over the last, we're going to do a year, okay, over the last year. So this is SQQQ. Some random stock that's going down. I don't know anything about it, but I know that it's just gone negative. So I want to give you an example of a negative one. So February 3rd last year. So we'll say February 3rd. This stock traded at 97.20. Okay, 97.20. And then today, you know what? Let's put the actual, this is 2/1/20, right? Today, it's at $14.17. This is 2/1/21. Okay, so we've got a year gap here, and it's definitely gone down. It's gone down from 97.20 to 14.17. Let's see what that means. So the absolute, you take the new 14.17 minus the reference. We're going to wind up with a negative number, right? Because we've lost money. If we bought this thing at 97.20 and now it's only worth 14.17, we have lost, we're going to use a negative sign here, 83.3, right? We've lost $83. Now let's do the relative. Now I'm going to be a little lazy here. And if you've noticed, the relative, the numerator's always just been the absolute divided by the reference number. So our reference number is going to be 97.20, right? 97.20, and then you multiply that by 100%. So I'm going to divide what's inside here first. Negative 0.8542. We'll go to two decimal places once we multiply by 100. So then this gives us negative 85.42%. Right out of the room there. So absolutely, we've dropped $83. I should put we've dropped $83.03, right? If I bought this at 97.20 and I sold it at 14.17, I have lost $83.03. But relatively, I've lost 85%, 85.42% on this stock. Okay. Okay. Questions? I'm going to look at some examples that they did just to kind of do these as well. But any questions about this example? Oh, your book does stock price rise as well. I did not know that. You know, I'll let you guys do those. I mean, you should be able to grasp this from the just a basic stock example. The last usage of the percent is percentages for comparisons, right? If we wanted to compare two values, we could use them as percentages. In your book, I'm just going to read from the book for a second. It says percentages are also commonly used to compare two numbers. Suppose we want to compare the price of a Mercedes to a Lexus. Now it's a $50,000 Mercedes compared to the price of a $40,000 Lexus. The difference between the Mercedes and Lexus is, of course, $10,000. But we can think of it as the Mercedes costs $10,000 more than the Lexus. We can also express the difference as a percent, where it would, of the Lexus price, I should say, a percentage of the Lexus price. So 10,000 over 40,000, which would be 25% more. So therefore, the Mercedes costs 25% more than the Lexus. So if you do this, you have to be careful. So if you're thinking of it as like how much more does the Mercedes cost compared to the Lexus, you really have to use the Lexus's value. Okay. Well, it's 10,000 more, and the Lexus is 40,000. So it's going to be 10,000 over 40,000, 25% more. And then your book goes over absolute difference and relative difference as well. It's very pretty much the same. It's on page 124. I'm not going to write it down. But let's look at an example of this in the real world. So your book goes over pay comparison. And it talks about the average pay for a full-time wage earner from state to state. Now, this is from 2009, it was released in 2013, but the data is from 2009. So, I mean, we're looking at 11 years ago. And it shows that New York ranked first in average pay, about $60,300. New York. And then per person, I should say. And then South Dakota ranked last at 32,800. This is South Dakota. You know what? You guys can read this. Let's look up data that we have now. I'm going to use a little bit different data. It's easier to find, and we'll update this. So let's look at median wages by state. And then we can look at Arkansas. Okay, so the data that is on Wiki, which we're just going to assume is true because it's from the Bureau of Labor and Statistics, talks about median wages. So we're not going to use this. If you want to look at their example, you're more than welcome to. But we're going to actually look at let's look at Arkansas and New York. Why not? So this is the median, which you would typically use median when you look at wages because it's the middle 50%, right? The middle 50%. This means 50% of the persons in that state that are of an age where they can earn an income make below, and 50% make above this number. So the median wage in Arkansas, let's find this, is $31.85. So median wage in Arkansas is $31,850. Now let's do New York just because they chose New York. New York is $44,999. So median wage in New York is $44,990. So it's now the book wants you to compare the average pay. Let's compare the average pay in Arkansas to New York. Compare the average pay in Arkansas to New York. So the absolute difference is just subtracting them, right? The absolute difference is going to be, now look, we've got to do the compared value minus the reference value. Based on the wording of the statement, we would use Arkansas as the compared value. So compare the average pay in Arkansas. So the compared value is Arkansas. This is going to be our reference value. Okay. So to get the absolute difference, it's going to be equal to compare minus reference. Okay, compare minus reference. So for us, that's going to be 31,850 minus 44,990. So I'm going to pop that in the calculator. And I wind up with negative $13,110. So what that means is in Arkansas, you would expect to make the median, I shouldn't say expect, the median income in Arkansas is $13,000 less, $13,110 less than in New York. But what does that mean relatively, right? So the relative difference, it's going to be equal to the compared value minus the reference, that sounds familiar, right, over the reference. Now, of course, we're still going to multiply this by 100% just to put it in percentage form. So we already did the compared minus the reference. That's right here. So I'm going to plug that in, negative 13,110. And then I'm going to divide that by the reference. Now, remember, the reference is New York here. So it's going to be 44,990. So we wind up with, let's see here, negative, we got to multiply that by 100%. Now, after you multiply by 100%, you wind up with a negative 29 point, let's say 14%. So that means you can expect to make almost 30% less in, I should say, not that you can expect it, the median income in Arkansas compared to New York is 30% less. That's the best. That's how you would write that. So we just have to be careful on the wording on this one. What's the compare and what's the reference? Okay, what's the comparative and what's the reference? Okay. And then your book goes over like the of versus more than statement. It says, consider a population that triples in size from 200 to 600. There are two equivalent ways to state this change with percentages. Using more than, you would say the new population is 200% more than the original population, right? Using of, you can say the new population is 300% of the original population, which means it is 3 times the size of the original population. Here we are looking at the ratio of the new. Yeah, so you look at that. That's on page 125. It talks about the difference between the of versus the more than statement. Okay, of versus the more than statement. Man, it was a lot to get through today. Yeah, percentages of percentages, which is always goofy. And then let's get to actually the solving part of percentages. It says, okay, steal it from the book. This starts on the bottom of page 127. It says solving percentages. Consider this statement. Retail prices are 25% more than wholesale prices. If you knew a wholesale price, how could you calculate the retail? One way to begin is by translating the more than statement into an of statement. So yeah, it would just be 100 plus 25%. So right, think about this. If we know that retail prices is 25% more than wholesale, the wholesale price. An easy way to convert this is you say, well, if we knew, the wholesale price, you would just add 25 to it, and you wind up with 125%. So the retail price is going to be 125% of the wholesale price. Okay, the retail price is going to be 125% of the wholesale price. So with this equation, we can find a retail price from a wholesale price. For example, let's say you are selling, what do we want to sell? We're going to sell something we got to buy and then sell. Let's think, like kind of reselling. Let's say let's say tomatoes. Why not? We're going to sell tomatoes. We're going to sell tomatoes, okay? And what we know about tomatoes is, look, we're not growing the tomatoes. That's not our job. We're going to sell them. So we can get them from the grower. We can get tomatoes from the grower. So that's our wholesale price, right? At, I have no idea, let's say $1.25 a pound. Okay. We can get tomatoes from the grower at $1.25 a pound. Now, retail price is 25% more than our wholesale price, right? So how much would the retail price be for the tomatoes? For the tomatoes, right? How much would the retail price be for these tomatoes? And there's just a few ways to do it, right? And your book goes over one of them. It says, oh man, I do not like the way it goes over it. Let's just look at the basic way. We know there's 125% markup on this wholesale price. So what you can do is actually take the wholesale at $1.25. I should have used a different number. And we know there's 125% markup from the wholesale to get to the retail. So then you just multiply it by 125%. Now you have to be careful. Remember, 125% is a decimal. So when you pop this in your calculator, you need to write it as 125 times actually 1.25. 1.25. Remember, 125% would be 1.25. So 1.25 times 1.25, actually. Horrible example because I used the same number twice. But if you do this, 1.25 times 1.25, we're going to round it to the penny. So it's going to be $1.56. So we would need to sell the tomatoes for $1.56 if we're going to make 25% more, right? If we're going to make 25% on top of the cost of our tomato, okay? If we're going to make 25% more on the cost of our tomato. I mean, the same is true. Taxes work the same way, right? I'm going to look up taxes real fast in Mountain Home. Sales tax. So right now, this is just from Google. Sales tax in Mountain Home, Arkansas is 9.31%. $9.13%. So if we wanted to get the total cost of an item in Mountain Home, like let's say, now if you order stuff online, they attach that sales tax percentage. But let's say we were going to go buy, let's go to GameStop. And we want to buy that new Oculus 2 thing from GameStop. And it costs $299. Okay. So I want to buy an Oculus 2 at $299. At $299. Okay. You got this Oculus 2, it's $299. But of course, if you bring $299 in cash, that's not how much you're going to pay. There's going to be tax on top of it. But you want to know a quick way to find out the total amount. Well, you can look, if the sales tax amount is 9.13, then the total amount paid is going to be 100 plus. 100 means the amount for the Oculus. 100 plus 9.13%. So it's actually going to be 109.13%. That's what you would have to multiply by, and you would get the total amount paid. Okay, so let's do this with this Oculus. we'd have 299 times, now we've got to write this as a decimal. So 109.13 written as a decimal would be 1.0913. Okay. And when you do that, so 299 times 1.0913, you get, now I'm going to round this to the penny, right? Would be 326 point, and actually would round up to 30. So this is the amount I should expect to pay at the GameStop in Mountain Home for this Oculus. If our tax is 9.13% and the Oculus, the cost is $299. So you just have to tack on to that 100% to get it in one step. Okay, to get it in one step. Okay, good. I want you to look at the last parts, and then I'm going to give you homework for this section. So in 3A, I've ran out of room here. Down here. In 3A, which starts on homework starts on page 131. Actually, I think it starts on 132. Page 132, 3A. For homework, I want you to do, actually, it's in yours is in here. So do the homework that's in Blackboard. I'll write it down for you though. For 3A, it's 1 through 107 odd. And I'll tell you, you could probably do every other odd and be okay in this section because you'll hit every topic. So if you're like, man, that's just a whole bunch of homework, I can't get that done in 2 days, Mr. Shirley, do every other odd, and you'll probably be fine. Okay, you'll probably be fine to do every other odd. Okay. Any questions about that? Get that homework done, and then you can ask me anything and everything that you're wanting, or that if you run into any questions from the homework. Okay. There was something I wanted to check out. Yeah, see, this next section, really 3B is what I was talking about. Okay. So I'm going to pause this here, and then give me 1 second. I'm going to start another video for section